Okay, so here's another question that popped up in the homework. In particular, we're going to be taking a look at number 3, but we're going to look over here at number D and look for a strategy that might work to solve this question. So in particular, we're looking at Pascal's number, his fifth, essentially his fifth row, which goes in the order of 1, 5, 10, 10, 5, 1. So those will be the order of our coefficients. Before we start, let's make sure we switch this to an A and a B type system. So we're going to say let's make those smaller case, let A be 2x and B be negative 1 over x. Okay, so we're going to start this way. So when we write this out, we have our coefficients there, which are a 1. So we have what starts out as a to the power of 5. Then we have plus a to the power of 4b plus a to the power of 3b squared, and so on. And then once we have all of our variables in there, we can put in our coefficients. And of course, once our coefficients are in there, that is basically the expansion of the entire thing. We just now have to switch our a's and our b's back into 2x and negative 1 over x. So there we have all the numbers that are just put into place. Now if you want to pause it, you might want to double check your solutions to make sure you've entered them all correctly, making sure that we still keep the entire number, the negative included, and that we have the proper exponents on all of our variables. Now this is a part where most people make the errors, is that they actually forget to actually reduce them, or as you're working out all these exponents, you forget the idea that when we look, for example, at the very first one, we have a 2x. Now most people would be quick to go x to the power of 5, forgetting that it's also 2 to the power of 5, which you can simply just put as being 32. So that would be reduced to 32 x to the power of 5. And as you go through that, you want to make the same conclusions there. You want to, it's 2 to the power of 4 for this one, which is 16x to the power of 4, and then we do the multiplication. If you remember your BEDMAS rules, it's always do the exponents first. So we get to the next row, we get 80x to the power of 4. And then right after that, we also have this negative 1 over x. Now, you might not think anything of it, but it actually changes the number significantly. You see, if you combine those two terms, you have 80, it's negative, 80x to the power of 4 over x. So you actually get a reduction in here. You're reducing, you can take this out, and it goes x to the power of 3. So the interesting part about this question is that you end up canceling out some of your terms, or at least some of your x's in the process. I'll do another term just so we're careful. So in this next one, we have 8 to the power, so that's 2 times 2 is 4 times 2 is 8, x cubed times 10, but remembering we still have basically negative 1 over x all squared. So that number, the two negatives, multiplying a negative times a negative, gives us a positive. And the 1 squared is 1, and x squared is, well, x squared. So this makes a big difference when you come to your next line. Well, let's combine these. We get 80x cubed all over x squared, and as a result, we find that this just becomes 80x. So again, a reduction. As b apparently gets bigger, we have a reduction in what x becomes. And the next term continues, similar fashion. So you're losing more x's. And the next term, you start seeing the x's show up as a denominator. And that'll continue right through until we lose our a, which is essentially losing our 2x. So you combine all those and you have your 6 terms right there, and you come to the solution shown here. Now a thing to point out here is actually that we start off with x to the power of 5, and it actually gradually goes x to the power of 3 to x to the power of 1 to x to the 0, x to the negative